All right, we're here part 2. We are going out of this book right here, Pre-Calculus Common Core by Glencoe, McGraw-Hill. Common Core, the best. It's not. You're going to be needing these for today. So we have Pythagorean Identities. We have, there's only 3 of them. 1, 2, and 3, and then we can just subtract things to make it look like there's 9. And then we have our reciprocal functions and, of course, tangent and cotangent, what they equal. So we will be using those today. We are on page 324. I did 1 through 10 in the previous video. So we're going to start with number 11 on this one. Let's go. So we got to have a lot of stuff canceling out. We have all this right here, and it ends up equaling 1. I tell my students, start out, if you don't know what to do, change everything into sine and cosine, and that's exactly what we're going to do right now. There we go. So I'm looking exclusively at the denominators right now. I'm going to find common denominators in the denominator. So just this down here, it would be cosine squared. So I have 1 over cosine squared minus sine squared over cosine squared plus 1 over, and again down here, this is my common denominator will be sine squared. So I'll have sine squared minus cosine squared over sine squared. So check it out. I have 1 divided by another fraction. Going back into elementary school, if we had a number divided by a fraction, that would become multiplied by its reciprocal, if you think back to that. So I'm going to have 1 times the reciprocal of this, which is going to give me cosine over cosine. That's not how you spell that. CO2. Nope. Cosine minus sine. Same thing here. We're going to do 1 divided by this denominator, which means we're going to do 1 times its reciprocal. And it looks here like we can just make the numerator into 1, right? Cosine squared plus sine squared. Only problem is our denominators are not the same. They're close, but they're not the same. So what I'm going to do is fix my camera a little bit. It's really crooked. So what we're going to do is factor a -1 out of here. That'll change the signs. So that becomes a negative sign, which is what we want. Positive cosine, which is what we want. That negative we factor out causes the top to become minus. So that plus changes into a minus because that's where the negative has to go somewhere, and that's where it goes. So now we have this. And as ugly as that is, we have something divided by itself. So that's gone, and I get 1 as my answer. So going back, if you don't know where to start, just start making things into sine and cosine. If we have fractions, you're going to want to find common denominators, and hopefully it'll work itself out like it did in that one. All right, number 12. Common denominators again. Let's do it. So these are our common denominators, these 2 together. So this left side is missing cosecant minus 1. This side is missing cosecant plus 1. And why not? Let's combine these 2. If I multiply these 2 pieces out, this is actually a difference of squares. That's like if I have like x plus 4, x minus 4. One's plus, one's minus, right? When I multiply those out, sorry, I get x squared minus 16. We're going to get the same thing here. We're going to get cosecant squared minus 1. Combining the top, we're going to get cosecant plus cosecant, gives me 2 of them. Negative 1 plus 1, that's gone. This here is a Pythagorean identity. That's this guy right here that you hopefully had copied down in the beginning. So that becomes cotangent. And let's separate everything out here. We have 2. Cosecant is 1 over sine. And then cotangent, it's in the denominator, so this is actually 1 over, I'm not even going to say that. It's 1 over cotangent, and 1 over cotangent equals tangent. So 1 over cotangent, that's this guy right here. Where'd it go? 1 over cotangent right here. 1 over cotangent equals tangent. That's where we got that from. So now, can you guys see that on the camera? Nope. Need to adjust my camera. So we have 2 times 1 minus, or 1 over sine squared over cosine squared. 2 signs on top, 1 on the bottom, so that one's gone. So I'm left with 2 times 1 over cosine squared times sine. 1 over cosine squared gives me secant squared, and that is our answer. There you go. You really got to know your algebra to be able to do this stuff. So pause and go back if you have questions. Actually, only my students are going to be watching this. You guys know how to get a hold of me. Number 13. So where do we start from here? We could actually change all of this into sine and cosine, and it'll be a mess, but we can get the right answer. Check this out. This is another difference of squares, 1 plus 1 minus. If I FOIL this out, I get that. And check it out. Where did I go? Right there. Cosecant squared minus cotangent squared equals 1. So we're actually done. Had you changed everything to sine and cosine, it would have gotten messy, but it still would have worked. But again, knowing your Pythagorean identities and recognizing that we're going to have a difference of squares here makes it all that much easier. 14. So we're getting into more difference of squares. This is the same thing, and I'll show you how. If I have x squared minus 25, I get x minus 5, x plus 5. What if I have x to the 4th minus 25? Okay, well that's x squared minus 5, x squared plus 5. That's what we're going to have right here. So we're going to have cosine squared minus sine squared. Hey, there's our answer. And we're going to have cosine squared plus sine squared. Cosine squared plus sine squared, that is our Pythagorean identity. This equals 1. So I have cosine squared minus sine squared times 1. And there's our answer right there. There you go. All right, number 15. We just had a problem like that. What number was that? Number 12, if you want to go back and look at that. That's the same problem here. All right, so here's our common denominator. Both of these multiplied together, so this one is missing one plus sign. This one is missing one minus sign. Looking at my answer, I'm seeing I got 1 plus 1, 2. That might come into play. I don't know. We'll see. Sine minus sine, so that's gone. So I'm left with a 2. Put our denominator in here. Foil this out. Difference of squares again. That's going to be 1 minus sine squared. So sines are gone. 1 plus 1 gives me 2. 1 minus sine squared I know is cosine squared. So let's write out every step so you can see what I'm doing here. 1 over cosine gives me secant. So I get my answer, 2 secant squared theta. All right, number 16. Same thing again, just like the previous one. Common denominators are here, so this one's missing 1 minus sine. So I have cosine times 1 minus sine. This one is missing 1 plus sine, so I have cosine 1 plus sine. All over, and again, I'm going to FOIL this out. I'm going to get 1 minus sine squared. So we have a few options here. If we distribute these cosines, it'll make a big old mess that we can't do anything with. So let's go ahead and factor a cosine out of both of those. So I'm going to take a cosine out of each of those, and I'm left with 1 minus sine plus 1 plus sine. All right, that's what I have. If I were to factor this back in, I would get our first line. 1 minus sine squared, I know that is cosine squared. Here we go. Sines are gone, negative and a positive, so I have 2 left over. So I have 2 cosine over cosine squared, which leaves me with, if I can cross that out, 2 times 1 over cosine, which gives me 2 secant theta. All right, let's keep going. Number 17. Just like what was that number? Number 14. Squared minus cosecant squared. Not cosecant, it's cosine. Cosine squared. And cosecant squared plus cosine squared. This here, cosecant squared minus cosine. Is it cosine or cotangent? Those are tangents. Oh my gosh. Sorry, folks. Change those, please. I wrote them down wrong. Cotangent, cotangent. There we go. Now we have a Pythagorean identity right here. This equals 1. Cosecant plus cotangent. Sorry about that, all 6 of you who are going to watch this. Here we go. Cosecant equals 1. That's a Pythagorean identity plus cotangent. Now I knew to do this because I was looking at my answer. I knew what we needed to get to. And at this step here, I couldn't quite see it, but I remembered this is a Pythagorean identity, which equals 1 plus cotangent. And now look, I have 2 of them, and that's what we're going after. So I have 2 cotangents plus 1. So you got to get a little creative here sometimes. Tell my students memorize those identities. It'll make these types of problems so much easier. 18. Let's go. Cosecant squared plus 2 cosecant minus 3. Remember years and years ago when I first started teaching this stuff, I came across this type of problem and it stumped me for a minute. What do we do? What do we do? Because this is kind of weird, right? We have a squared and then just a regular, then we have a no cosecant. Check this out. So I'm going to say, let's factor x squared plus 2x minus 3. Cosecant right here for the x's, but I'm too lazy to write them out. If I factor those, I'm going to get minus 3, positive 2. So I get 3 and negative 1, which gives me x plus 3, x minus 1. And that's what we're going to do. Cosecant plus 3. Cosecant minus 1. And what do we do about the bottom? The bottom is a difference of squares. We've done a bunch of those already. So I know that's going to be cosecant plus 1, cosecant minus 1. Oops, theta. Minus 1. That's gone, and we are left with our answer. A lot of foiling, a lot of Pythagorean identities. So we are skipping 19. We're going to head over to 20. So that is a lot of stuff to pare all the way down to sine. Gosh, I need to fix my camera. Bah, stay there. So I'm going to FOIL this out. Yikes, it's going to be ugly. That's okay. Cosecant minus cosecant cosine plus cotangent minus cotangent cosine. Okay, that's just foiling this out. I haven't solved anything out yet. Let's get everything into sine and cosine. Check out all these denominators. We can actually rewrite this one, and since it's video, you guys can go back and see what I did here. Oh, I almost erased that. Cosine can't. Just put the cosine on top. So they all have sine. So we have these are gone here. Cosine over sine plus cosine over sine, those are gone. I'm left with, on the top, 1 minus, actually be this minus here, 1 minus cosine squared, all over sine. 1 minus cosine squared, of course, equals sine squared. Cross it out, and I am left with my answer. Let's see. All right. We'll end it on 21 here, and then I'll finish making the third video. Weird, right? We have sine times tangent, and now we have tangent minus sine as our answer. How are we going to do that? Well, like always, let's make this into sine and cosine. This is something you're just going to have to know to do, and I know that's a horrible thing for a math teacher to say, hey, just know how to do this. We need to get a subtraction sign in here, and we don't have that right now, so we have to create something with a subtraction sign, and I know sine squared is 1 minus cosine squared. Distribute that. That's going to be the trick on this one, is knowing to do this. And again, why did I do that? Because we had a subtraction sign here and we didn't have any subtraction signs here. We had to create one. So that's why I did that. So I have sine squared over cosine squared. That's this sine over cosine. Minus sine squared, I'm just distributing, cosine squared over cosine squared. And we have our answer right here. Sine over cosine gives me tangent. Minus, cosines are gone. I'm left with just sine. There you go.